Welcome back to our video series. As we saw in the last video, when scientists do experiments and carry out investigation, you remember they collect data, and that data they put in a data table. Now they want to better understand that data that they've put in a data table, so they try to visualize it. Okay, they try to take a picture, that's how I would say it, or just in an interesting way, they try to take a selfie of their data to better understand and visualize what is happening. And that picture that I say they take is what we call graphs. Graphs help scientists see the trends that is taking place in the graph and to also analyze what is happening in the graph. There are different types of graphs. You have the bar graph, you have the histogram. The histogram don't have space between the bars. You have the circle graph, and you have the line graph. In this video, I'm going to concentrate on the line graphs. You must have seen these types of graphs in newspapers, magazines, and even in schools. So when scientists look at the graphs, remember, they're trying to analyze the information because it helps them visualize the data. And when they're trying to analyze it, they look for trends. What are trends? There are different ways we can explain how trends are in a line graph. When the line is going down, it's either decreasing slowly, or you can say it's decreasing very fast. When the line is going up and down, it's fluctuating. And when it's basically on a straight line horizontally, you can say it's staying the same. When the line starts going up, just like in decreasing, it can be increasing gradually or slowly, or it can be increasing exponentially. When you want to draw a line graph, there are two important lines and fundamental things you need to know. The line running vertical is the y-axis, and the line running horizontal is the x-axis. Now, when you look at the line, always starts with 0, then you can now, depending on your data, determine how to space them. And remember, the spaces need to be the same. In this case, it's increasing by a factor of 2 points. So depending on your graph, the same thing goes with the y-axis. So we're going to see some fundamental rules that we need to follow when we're drawing our graph. This is called the SALT rule. What does each letter stand for? S stands for scale, A stands for axis, L stands for label, and T stands for title. We're going to understand how this rule works for a graph by looking at carbon dioxide in the atmosphere over a period of time. Okay, so scientists collected data, and this is the graph they plotted. So we're going to apply the SALT rule to see if this graph is well drawn. So the first thing we're going to look at is the scale. So what does the scale tell us? You look at the x-axis and you look at the spaces between them, and that is 50 years each. So the x-axis, it's okay. You look at the y-axis and they have the same amount of space between them. So in that case, the axis is correct. The scale, sorry. Then you look at the axis. So you look at the x-axis and you look at the y-axis. So we have the x-axis and we have the y-axis. Time, it's always on the x-axis, so it's correct. The next thing you want to look at is the label. In this case, we are looking at if the y-axis is labeled, so you have year and you have carbon dioxide equivalent, so it's well labeled. The last thing you want to look at is the title. So it has a title. So in this case, this graph fulfills the SALT rule. And look at the trend. You have gradual increase, then exponential increase. So get ready to see if you can draw your graph using your data from the last class.